This time on the laboratory, we're going to look at Goosebumps Manor. This was sent in to me. The person that owns it was trying to repair it, and they removed the bottom. There's some lighting issues, and can't fault them for trying to repair it, but I see some issues why they're having a problem. They also sent tape to it, the resistor pack that goes inside here, and what I did is I marked them. So from left to right, it's 47 ohm, 33 ohm, and 150 ohm. And that would be, it's hard to see in the light, this one here, which is the 47. The one in the middle here is 33, and the one at the end is 150. You can look up the color bands to get the numbers by cross-referencing them online, or you can use a multimeter and set it on ohms. But coming in and looking inside this house, we have the input right here, which is 4.5 volts, and even tells you right there with a little sticker, in case you don't have yours or you want to get one. And coming off of this cord here, which is your on-off switch, is a red and white wire. The red wire is right here. The white wire has been soldered to this LED. This LED cannot handle 4.5 volts. If it does, it will pop or burn out. It won't really pop like a light bulb, it just burns out. So we are going to, first, I'm going to separate the incoming power wires, or switch wires, from the lights at the moment, because there's no resistor. And then I'm going to push them up inside so they're not in my way. There's a yellow and white wire right here, which has been twisted and soldered together. This is one LED, so one side's negative, one side's positive, so they cannot be soldered together. So we're going to cut that. That's the porch light LED that illuminates the porch. And the cat, or not the cat, the door, the stairs right there. So this green wire, which has the other end of this LED connected, is just twisted on. We're going to remove that. The green wire and the white wire, let's see what they go to. A lot of shadow in here. Need a flashlight. Looks like they're attached to an LED that's glued to the back of the unit. So that's the green and this white wire here, because they use white a lot. It's more of their common color. Now we have two sets of white and one gray, one purple, which are these two. One goes to the light here, one goes to the light down here, and these also are soldered together, which means that the negatives and positives are connected. So we're going to trim those off so we can actually test it, and then solder them all back together, solder them back to the port, solder them back in with the off-on switch, and if any of the lights are burned out or damaged, we'll have to replace them. This is an older piece, and it's actually really hard to find a picture of to see what the lights look like. So I was actually surprised when I was trying to locate, so I can see if they're purple or green or orange or so on. So, because the color of the LED determines the power of the resistor. That's why these resistors, there's 3 different resistors coming off of the incoming power, is because each LED has a different voltage and amperage draw. So what I'm doing now is I'm stripping the ends of the wires so I have fresh copper so I can test them. And I have a volt, or a power supply, not a voltmeter, power supply off to the corner of the screen that is set at 2 volts. 2 volts can test most LEDs and it won't damage them. You can do it with a AA battery or a C battery or D battery and make some contacts as well. Those are 1.5 to 1.8 volts depending on how old they are, to do some testing. But I'm going to test each light individually, and what it's going to tell me is this meter on the side gives me the amperage draw. because the amperage draw is important. The amperage draw lets me know which resistor goes where. Most LEDs are between 10 and 20 milliamps per color per light. Also, by doing this, I'll be able to tell if the white wire or the red wire is hot. So that light's not coming on. So, I'm sorry, this one, purple. Still no light. I need to find out if they're using the white wires as the positive or the colored wires as the positive. So they use one as a common constantly. I'm thinking all the white wires are all the white wires are negative. So the inside house light is green. It's a really dull green. So let's check this light. So I have my voltmeter now, or my power supply set at 2.5 volts. And so this is the color of the inside of the house. It's that really dull green. You probably can't even see with this white light. So it's a really dull green. And this is designed to run at about 2.5 volts, because if you watch, I'm going to go up to almost 3. It changes to orange. That's not designed to do that. That orange means you're burning out the LED, which is why these resistors are very important. But the reason I want to test all the LEDs first is to make sure none of them are bad. So we know that the white wire is the common ground. So there's the yellow porch light right there. And now we're going to do this white wire and this purple wire. And that's supposed to turn on the light over here, which it is not. So that light's probably bad. So now we're going to go to this white wire and this purple wire, or gray wire. It also has no light. So it appears that the two lights that illuminate straight up are bad. So you got one there, and you got one right here in this green cap. Now, if I remember right from looking it up online, they are purple lights. Just going to remove some of the glue. So I'm not sure where this one went. I'm assuming it was just glued in the back in here somewhere. It could be wrong, because there's no protrusions where this one would come through. So I'm going to go with it was glued on the inside. So this thing runs 5 LEDs, 3 in the front, 2 in the house, and the 2 in the front here are bad. They do not turn on no matter which way you switch the wires, just in case the wires were reversed. So they probably got overdrawn or overpowered, sorry, and they probably smoked. Yeah, there's nothing. So negative wires, which are white, will be soldered together and then soldered to the power port, which is really hard to see. It's the black power port right here. That would be on the, let's see if I can get it on the camera here, on the inside. You'll see, put up some light. There we go. You got a pin here, and then you got a double set of pins here. The double set of pins here, one of them is negative, and one of them has no power, and then this big fat one is positive. So the resistors will get soldered back to the positive, and then the negative will have all the negative wires, basically. And what we'll do is the switch, which is the red and white wire that's tucked up in there, one side gets soldered to like the positive, and then the other side gets soldered to the resistors. Or if you want to make it a negative switch, you solder all the negative wires to one side of the switch and the other side to the negative pin. Because when you have a switch, it's only interrupting one side of its current path. You can do positive, which is a positive switch, or negative, which is a negative switch. Low voltage, it doesn't really matter. I prefer negative switches myself, but that means everything inside the house is constantly powered until you engage the switch. So if you don't like that, you can do a positive switch, which means the power ends at this. So, or starts at this when you turn it on. So it is optional at that point. But the first thing we're going to do is I'm going to find myself a set of LEDs to replace these. And then we're going to get started in making this light up at 4.5 volts, giving it back its color, its glory, and then it'll get ready to be sent back to its owner. I do know that there are a few pieces that came off in shipping, like the piece that goes right here. I do have those pieces, this piece and this spire. I got them out of the box, and I'll probably glue them back on before it leaves. So if you're like, oh, it's missing pieces, yeah. Unfortunately, you should have seen the box this came in. It was completely crushed, had a hole in it, all the packing material spilling all over the place when they brought it up my driveway. And surprisingly, it's still intact. After looking at the box, you'd swear to God it would be smashed into little pieces. So anyhow, I'll be back in a minute with some LEDs. Alright, I got 2 UV bulbs, which is also known as purple. So there you go. I'll turn this light off again. This is just an LED tester made from a 9-volt battery. There's a resistor in here, so if you did a 9-volt battery, you just burn out the LED. You can buy resistor testers, or excuse me, LED testers. My gosh, man. You can buy them online too, or you can make your own. So here are 2 UV or purple LEDs to re-illuminate the front. And now to get these out, this one is just glued onto the top of the grass. This one is also glued on top of the grass, but it has a shield to deflect the light away from your eyes. On this one, they're using the keep out sign to prevent you from seeing the actual light itself. A lot of times these will just pop off. They're glued on, but the glue gets brittle, especially this house. This house is like 17 years old. There we go. So it popped off, and the LED came with it. The solder physically tore. I wonder if the solder wasn't just connected. Let's see. Yep, so it's just a bad solder joint because light works. Hopefully you can see it again. It's blinded by the big light. So I wonder if this is the same way. To get to these, you do have to remove the rest of the base. Or at least down to that light. There's the wires for the one. And 2006, so this thing is 16 years old. And we're going to check this LED as well again, see if maybe it's just got a cold solder joint. I'm going to pull the wires through. There's some more glue. There we go. This one, though, I'm going to check with the machine because it still has the actual leads on it. No light. So now we'll actually touch it to the actual pins. And no light. So this one is bad. Has a greenish tinge to it because I got some of that green paint on it. Yeah. Bad LED. So we only need one LED. And I'm not going to use the original wire. It's just going to go in the garbage. I'll run new wire so I can ensure we get a good connection. So once you pull this back, there are, and this is very common in porcelain houses, there's grooves that they feed the wire through, and then this is recessed. So just the edges of the mat actually stick. And the wire has to be fed through and then soldered, and then you put a dab of, I would use hot glue. You can use the hard glue like Gorilla, and then you pull it back through, let it sit, and that gives you your light, and then feed the wire back in, solder it back up, or if you don't use solder and you twist the wires together in a piece of electrical tape, whatever you need to do to make it work is fine. Throw away this light since we know it's bad. So let's get this thing started. Gonna fire up my soldering iron and get some wire. I know I have some thinner wire around here somewhere. So I'll use black and red wire. First thing to do is strip off a little bit on the end. Then I'm going to pin the ends. So. Now, on an LED, there's two leads, one shorter, one's longer. The shorter one is negative, and if you don't have the leads where they're cut level, there's a little flat spot on the side of an LED. It's hard to see, and that flat spot also indicates negative. And now these leads are going to be way too long, but what you can do is stick them through and fold them over, and that's what I'm going to do, because what that does is it also adds a little bit of support. And I'm going to use a set of helping hands to tin the LED and then solder the wires on. So, since the positive is going to be red and the negative is going to be black, the black one gets soldered to the smaller lead or the shorter lead. And then the red one will go onto the longer lead. what Lemax does is to keep these leads from touching each other, they use the hot glue. And when we put this in and glue it, I'll do the same thing. If not, you can use heat shrink or liquid electrical tape, so on and so forth. So, just to make sure that the light works and the solder joints are good, I'm going to split the ends, strip the ends, there you go. Of course, now that they've been stripped, the wires are fraying. I'm trying to get them into the hole. So, put them in the hole, pull the LED through, and I'm going to hold the LED in and I'm going to fold them over. So it looks like that. And that fold over will help hold the LED in and give me more surface to hot glue it. Now I'm just going to pull this back a little bit more so I can get the red and black wire through and not get stuck to the adhesive, which is getting stuck to. So, there. Yeah, and I do know I have too much wire, which is completely fine. We can trim it. But what I'm going to do is, because this wire is so long, I'm going to solder it to this light and then cut it in the middle and reconnect it inside. So I'm not wasting the wire. So I'm going to fix these ends. So they got tangled up in the mat. We're going to re-tin them, or we're going to tin them. Alright, so I know facing into the house that the one on the right is the negative and the one on the left is the positive. That's facing in, again, in towards the house, like it's going to be mounted. And I'm going to re-tin these. It's got a lot of old solder. A lot of the times when the solder joints break is because the houses are made with lead-free solder. And lead-free solder gets brittle and doesn't last this long. But it's, you know, they use the non-lead solder because they say it's better for the environment. I don't know, people throw away stuff because the lead-free breaks and it causes premature failure, so it's a trade-off. Because then when you throw it away, it's just in a landfill. Probably didn't get a good tin job. There we go. Apparently this one does not want to glue into place here. Come on. There we go. That's good. So you always check your connections. They're good. And you're like, oh, it doesn't go through. And this is where we're gonna snip and feed. Same thing. Gonna pull away some more of the sticky base on this corner so I can get it down the track. Except I'm not stripping the wires, so they're less likely to catch. And then pull it through. And feed it flush. so. And now these don't protrude as far, because again, we're using the original light, but there's still enough of a gap that if they're too close, you can separate them with something. I'm just going to use the tip of these needle tweezers. And then when you put the glue in there, the glue will also hold it as well as isolate the two ends so you don't get a hot knot connection. So no shorts. Long pants season. So. Now, UV bulb, they run at a much higher, or purple, if you call them that, they run at a much higher voltage. They run closer to that 4-volt range. Most of the ones I have run between 4 and 5. So most likely the 33 ohm resistor is the one that goes on the UVs. You can always look them up if you're not sure. You can just use the search engine of your preference, Google, Bing, Go, DuckDuckGo, whatever, and you can look up resistor resistance ratings based on a 4.5 volt circuit. So the 33 ohm one, which in that resistor bank right here, is the guy in the middle. This one is most likely going to be the one that goes to those. The 150 ohm is going to go to the lowest drawing one, which the lowest drawing one is probably going to be this guy right here. And then the 47 ohms probably go to the green. So we'll just double check that real quick. So if you don't have a voltmeter, one way to test it is, we know that the 47 ohm is the one on the end. So if I just wrap the wire and connect it, like so, the green light is on. Let's turn off. Hopefully you can see the green light. That's at 3 volts. That's 4.5. Now we'll go up to 5 because some of them power supplies have electric power, and it's still green. And the reason I kind of figured the resistor color codes, have been doing this for so long, but the 2 green ones in parallel would be on the 47 ohm resistor. The porch light would be on the 33 ohm resistor. I'm sorry, the 150 ohm resistor. And then the 33 ohm resistor are the 2 purple lights right there. So if you want the color codes, besides looking them up, let's see if I can see them. They're so small. So the 47 is yellow, black, black. The 33 is orange, orange, black, and the 150 is brown, green, brown. So now we're going to wire this thing up. And like I said, I'm going to make this a negative switch. So I am going to put all the negatives together. And then I'm going to solder those to one of the 2 wires from the switch. It was probably a positive switch when it came in from the factory, but we're gonna change it up. Only because, again, I like negative switches better. That's how I wire the cars that I work on. It just, to me, is a better way to stop the flow of electricity. So gotta pre-tin everything so we can solder all the wires together. Or if you want, you can use a wire nut, a small one, to connect all the common wires together. If you don't have a soldering iron, you can twist them all together and cover them in electrical tape or hot glue. There's many ways to do it. It may not be pretty, but how often are you going to be inside your house looking at what's in the house? Most of us just want them to work and not burn out. So what's nice about this house is it's there's no animatronics, it's just lights. I gotta solder new wires on this because it only has the one, so the green wire is the negative. That's why I needed to remember. So I got some. I'm not sure where this went in the house again, but I am going to glue some longer wires and try and put it farther higher up into the house since the other one's right here at the base. So if I can glue this greener one up high, it'll help illuminate the top windows. So I'm going to use a little bit longer wire, and we're going to solder this thing up. Whenever you're soldering old solder or removing stuff from old solder, it's best to put new solder on it to get better conductivity so you can get the old stuff off. Get that old stuff off. There we go. Now, one thing I do when I do stuff like this is I purposely strip more than I need, solder it, and then cut the end. That helps reduce the chance of the fray getting in my way. So it's a lot longer than I need, but it allows me to solder and cut to length. Now, of course, if you don't have enough wire to do that with, like you're using the OEM wire, then don't do it. Make sure that the solder joints are good and we get good connection. That out of here. I don't know if you can see the lights on. So we got the green. Good to go. Now the switch or the power port's loose, so I'm going to glue that back in as well. But now I need to see which one of those two pins. I said that one is negative and one is nothing. It's just a mounting pin for soldering to a board to help hold it. Which one is which? So if you have a multimeter, set it to ohms or continuity. And then you want to stick it inside here where the metal spring is, which is laying on its left side. This way, the spring is on the top. Okay. So, of the two pins, It's the inner pin, the one closest to the positive. And we'll just make sure the positive's got continuity, just to ensure that the internal of the barrel isn't broke. It's just hard to hold it on that pin, it rolls off. Yep, so the center's hot. So you got 2 pins and the center pin, that's hot, and then this inner pin right here that sits like that is your negative, this outer pin is nothing. They do that a lot on the barrels connectors to give you an additional point for soldering to mount it to a circuit board. If you solder it to the wrong one, nothing happens because it can't turn on. Now, because everything's so small, I'd recommend magnifying goggles, so you can look like Ray from the Ghostbusters. And I need additional light to see inside, just so I can tin the connections on the inside. Try and do this without melting my the wires I just did. Now we're going to take all the negative wires, which are black or white, depending on if it's the OEM or the new wire, and we're going to solder them together onto that negative pin. So let's get this started. Now, if it doesn't reach, you can also solder them and then solder a little piece of wire on that then goes over to the negative. Let's get this guy put into the house as well. Just leave it out. So I'm taking all the small wires and twisting them together so I can solder them together in a bundle, and then I'll solder on the new wires. Now you can do this any way that's easy for you. I just do it this way because the new wires are thick and a lot easier to deal with than the old thin wires. When I do rewires in houses, I use a little bit thicker wire. It's not as susceptible to breakage, and the ones I use are copper. The ones that Lemax uses are tin. Copper has a better flow of electricity than tin, but tin is still completely fine. It's just a cheaper material. As long as it conducts, you're okay. So they're all connected. I'm going to add a little bit more solder to fill in the void where the wires are separating, like that one just did, due to the small void. And because it's so hot, all right, so all the negatives are now connected. Now, this is where you're probably going to need a pair of needle nose pliers or tweezers because the power port is inside the house. And trying to fit your fingers in there and not burn yourself on a soldering pen, probably going to be really difficult. And I'll tell you, second and third degree burns from your soldering pen will leave a lasting impression. And if you can't see, add light. I'm also going to wet the tip of my soldering pen. Too many wires in my way. There we go. The other option is you could technically pull the switch out and solder it. Oh, excuse me, the power port, not the switch. There. A little bit bigger solder bubble on the thing. Bigger the glob, better the job. Now comes the hot wires, which those we'll solder on separately, of course, because each set of wires is a different ohm resistor. So I'm going to first slide this green LED up inside. Like that. And I know that the two purples are the same resistance. So those I'll twist together. Before I solder them. So the two purples are now twisted together. I'm going to solder them together. I know that the yellow wire for this is independent. So now we just need to solder the other LED that's in here that's green to the new green LED wire. So same thing, I'm just going to twist them and then solder them. Yeah. So now we only have 3 sets of wires. We have front porch, 2 front illuminations, and the inside house lights. And now we got the 3 resistors. So the inside house lights will go here. The porch light will go here. And then the purple will go here. Pre-tinning your wires makes everything a lot easier. So if you can do that, do it. because even though they're resistors and they slow electricity, they still get really warm when you're soldering. So I'm going to use the helping hands to, 1, hold it, and 2, stop me from burning my fingers on the sides. Alright, so there's the porch light. A little bit more solder. There is the front yard. And now we'll do the interior lighting, which the green wire is so short, it's just going to be a little bit of a little finagling here. There we go. A little more solder. Use this to hold it. There we go. I'm going to turn on the hot glue gun and pull those off. So we need to clean up this solder ball, so we're going to knock the solder ball off, and now I'm going to put new fresh solder on. Those are soldered together. Now we need to connect it to that hot pin. And this is the fun part. This is the part that's going to be a little difficult, because now we got all the wires in the way. We got a pack of resistors that you'll want to bend a million times to break the connections off of. Oh, didn't get it. So let's try a different angle here. Pull out the green LED that's just floating at the moment, and we're going to try this again. To actually just make a jumper off of it to those resistors, because I can't get the soldering tip in there. So take a piece of wire, I'm starting to burn everything else because the sides of the soldering pen are touching the other wires and the foam base, because there's not a lot of room. So I'm going to tin a piece of wire, and this will allow me to solder everything outside of the house base, and then I can just coat all this in hot glue, keep it insulated from itself. Turn this back off since there's a slight delay. Even with the more room, I still can't get in there. This is where you need to have patience and just take your time. And if you truly don't want to fight with it, you can try and remove the switch or the power port from the back. Just remember that you got to solder all the wires through the hole and then feed it back in. Maybe I got it. Do not. Man, this does not want to solder. That piece of wire was tin, so I'm going to try a piece of copper and see if it works better. There's so much solder in here, I should be able to solder it since it's all new. The old game of Operation. Well, instead of getting the buzzer that scares you, you can just burn yourself or melt things. So it's a little bit more dangerous. There, copper soldered right on. So, perfect. So that's what I mean by making a small jumper wire. It allows you to relocate the stuff outwards, away from what you're doing, since it's all recessed. Since it worked, I'm just going to tin the new wire on the inside here, and then we're going to solder it to this resistor pack. Yeah. So let's test it before we hot glue it all into place. You eagle-eyed people probably realize I forgot to solder in the switch. Oh gosh, you gotta love that. Not a problem though. Just gonna break the solder joint here. We're going to tin the switch wires, and we're going to put that in line. So if you're doing this, make sure you get the switch. If you tuck it out of the way, make sure you find it again. So that was my bad. No. Now, because of my mistake, it's going to be a positive switch, which is fine. I forgot to solder the negative wire into the negative bundle, or the switch wire into the negative bundle. There we go. Now, it should be good. Is the switch bad? Might have a bad switch too. I'm just double checking the solder's all on there. It didn't fall off. think the switch is bad. I'm sending power directly from the back of this unit into the switch. And the switch, yeah, it's detecting that the switch is there's a problem. That's weird. Let me desolder these wires and we'll check it all. I'll desolder the one side just to check it out. It's going to be hard because I'm going to get my finger in there again. Tweeters. Alright. Solder. I see what the problem is. The switch may still be good. The solder glob fell, and it was causing a solder ball, and it was causing it was causing a small short. It's such a tight, cramped fit. So I'm going to resolder it. I'm going to solder it on the other side. See if that'll help prevent any issues. And what I mean the other side is, those are pins, they're flat pins. Instead of soldering on the right side, I'm going to try it on the left now. And see if that helps out. Where's those? Soldered, but it's not a really good bond. That's a better bond. There we go. So you can see the porch light, the purple lights, the green lights are on. So I am going to now hot glue this all so I can shove it in and then show you it once it's all put into place. And I'll do it with the lights off so it's a lot easier to see. So basically the solder ball that I had put on there, it was arcing. I saw a small spark between the negative and positive terminal. So I just redid the solder and put it on the other side. So that way it's not as close to the positive terminal. So I'm sure you all know how to hot glue. Just to save on time, I'm going to pause it for a moment. I'm going to hot glue all the wires so they don't touch each other, and then use a set of long needle nose pliers, maybe these or these right here, to get that other light higher up and glue it in. So I'll be back in just a moment. Alright, I went and got some of the pieces. So I glued the spire back on and the tombstone with the vulture. This was not in the box, so I don't know if it fell out into a big hole that was in the side of the box or if it's still with the owner. So there you go. So you got the two front lights, that light, and they're really hard to see, especially on camera, but inside the green lights are glowing. The camera doesn't pick it up because it's getting swamped out by the brighter lights. So didn't expect it to take as long as it did, but It took over almost an hour and a half, 2 hours to do this. Basically rewiring and replacing one light and going from there. It's not a fast process, is what I tell people. Usually most of these videos I make are hours long due to the fact that this is why it takes so long. This was pretty much, except for the gluing part, this was a complete walkthrough from beginning to end on how to repair a house. And the videos I post up that are half hour to an hour and a half, they're 2-3 hours. So a lot of it I don't film due to the fact it's just monotonous and you'd get bored, stop, skip, whatever. You probably already did. So, but there we go. Goosebumps Manor, a non-animated, light-only house, no volume, no sounds, no nothing. One new UV LED, and then rewiring everything. You could replace both the same. They are the same brightness, but they if you wanted to replace them both so they're the same age, you can. But other than that, that's it. Everything's glued in the bottom. Now he has the base, so he'll have to glue it in himself. But I ran some glue around the edges to hold the wires so they don't fall out. So when he glues the base back on, they're not protruding. And then I ran a bead of glue down each one of those soldered connections to keep them from arcing, shorting out, or touching. So that's it. Thanks for watching the Goosebumps Manor rewiring and replacing one LED. So if you have a house with an LED, this gives you an idea how to do it. Now the ones that are in the bases are usually pretty easy. The ones that protrude through the wall of a house, they're a lot more difficult. I might be doing one of those soon. One of the pieces I bought, the new laboratory for 2022, the green LEDs on the side, has a loose connection or a bad LED because they flicker and they go out and then you have to smack them to make them turn back on. So I might show you how to replace them when they protrude through the side of a house. Because again, the bases are very easy to repair because you just peel the bottom off and there's usually a hole. It feeds the wires, cut them, pull it out, replace the LED, solder them back in, you're good to go. So, all right, till the next one. Thanks for watching. Have a good one.